Hello everyone, welcome to Mthobisi Mhlongo's Maths and Science YouTube channel. Today we're looking at the Eastern Cape Grade 12 trial exam from last year, Physical Science People 1. And in today's question, we're going to be looking at question 2, which is Newton's laws of motion. We have a truck of mass 1,300 kilogram that is connected to a car of mass 950 kilogram by means of an extendable massless rope, which is rope R, and it pulls the car along the straight horizontal rough road, and the engine of the truck applies a force of 9,000 newtons to move the truck car combination to the left as is shown in the diagram. And the truck experiences a constant frictional force of 3,500 newtons, and the truck and car move at constant velocity. Now that constant velocity is written in bold, so which means it's very important, and we ignore the effects of the rotational wheels. First question says, a learner states that if the truck comes to a sudden stop, the car will continue moving at a constant velocity. Now, which physics law did this learner apply to make the statement? A law that talks about a body that... No, I left it. A law that talks about a body that continue moving at a constant velocity is basically Newton's first law. So for 2.1, answer would be Newton 1, or Newton's first law, which says a body remains at rest or continue moving at a constant speed unless a non-zero resultant force acts on it. And in 2.2, they say draw a labeled free body diagram of all the forces acting on the truck, and that is 5 marks, which means there are 5 forces that we have to look at. The truck is going to the left, being pulled by a force of the engine, and the truck experiences gravitational acceleration and with normal force, and has a rope attached to tension and experiences friction. And then that makes our 5 forces. Next question says calculate the tension of the rope connecting the truck and the car. Now we're looking at the movement of the car and the rope. They are going towards the left, so everything left you take it as positive. Left is positive, but remember that they said constant velocity. If it's constant velocity, that means the acceleration is equal to 0. Why? Because the v final minus v initial will be 0. And therefore, we have to calculate the net forces that are going to that direction. So we start by saying F net is equals to MA, and that will give you a mark. And F net is equal to 0. And the total forces as drawn in the free body diagram that are going to the left and to the right is 1, that is F that goes to the left, and the friction going to the right, and the tension going to the right. Now, if we take the force F, which is the force applied we combine it with the negative friction plus the negative tension, because we're choosing our left direction to be the positive side. And then we will have that this is the F is equal to a positive friction plus positive tension force. Now, we were given in the statement that the engine applies a force of 9,000, which is that F, and the tension, or well, not tension, the frictional force is 3,500. So we substitute that, we get 9,000 is equals to 3,500 plus the tension force. Now, tension force will be equal to 9,000 minus 3.5, which is equals to 5,500 newtons. Second question says, calculate the coefficient of the kinetic friction between the car and the road. Now, the car experiences a kinetic friction, so that's 2.3.2. And the two forces that are moving in the car is the kinetic friction and the tension. So the tension force is going to this direction, and kinetic friction to that direction. But we know that kinetic friction is given by mu k n. And in this case, the n is given by Fg, which is mass times gravity. So this is mu k mg. Now, tension is going to the positive direction, and friction is going to the negative direction, as we have stated above. So this means that F net will be equal to mass times acceleration, and A is equals to 0 because the car is also experiencing what? Constant velocity. So F net is equals to 0, and the tension is positive plus a negative kinetic friction, which is equals to 0. And then we know the tension that we calculated was what? 5.5 thousand newton, which is equals to Fk. But 5.5 is equals to Fk, and Fk is what? Mu k mg, or you can say mu k n, but we know that the normal force is the same as the gravitational force. So now, by substitution, the mass of the car is 950. So this is 5.5 is equals to mu k times 950 times 9.8. When we divide both sides by 950 times 9.8, divide by 950 times 9.8, and we divide, and we find that mu k will be equal to 0.5907. So we can say 0.59 or 0.591. So it's just the coefficient, so it doesn't have a unit. Last question. The rope between the truck and the car suddenly breaks, and the car continues to move to the left before coming to rest. Now, this also proves the answer from 2.1, that the body will remain at rest or continue moving at a constant speed unless a non-zero resultant force acts on it. So, calculate the magnitude of the acceleration of the car after the rope breaks. Now, we said the car experiences frictional force. So since tension will not be there, the only force that will be acting will be the frictional force, which goes to the opposite direction, since we chose the left side to be a positive. And therefore, F net is equals to MA is no longer equal to 0, because the car is not moving at constant velocity. It moves at a velocity, then it comes to rest. So therefore, this has an acceleration. And this is just minus friction, because friction is opposing where the car is going, which is equals to 950 times the acceleration. But acceleration is equals to minus friction over, well, it's not just friction, it's kinetic friction. Minus kinetic friction over 950. Now, acceleration is minus the 0.591 multiplied by the mass, which is 950, multiplied by the, because this is the same as minus mu k times mass times gravity over 950. So in the substitute now, it's 9.8 divided by 950, and then we get that this is minus 5.79 meters per second square. Now this is negative acceleration. Negative acceleration being applied going where? To the right. So if we have to rewrite this, it would have been 5.79 meters per second square to the right, because that is an acceleration that is trying to oppose or the motion of the car. So it's negative acceleration. And thank you for watching, and please like, share, and subscribe. Thank you.